Hello everyone, welcome back to my channel again. So again in this video let's go with a model question paper of electric circuit analysis for AAA and ENC students. The continuation of that now. So now without wasting time, let's go for the questions. See, module 2, question number 4, state and explain superposition theorem. So I apologize that I explained instead of Thevenin's theorem, I explained superposition theorem in my previous video. So for that compensation here, instead of superposition theorem, I'll explain Thevenin's theorem. Then they asked two questions for B and C. One is Thevenin's equivalent circuit, and the one is for Norton equivalent circuit. One is DC circuit, and the one is AC circuits. So hopefully you guys can understand the session. So that without wasting time now, let's go for the question number 4A, that is state and explain Thevenin's theorem. Statement. So most of the students fail to write a statement in examination, so that practice statement and explanation of each theorems, that is Thevenin's, Norton superposition, as well as maximum power transfer theorem, along with the derivation of that now. So what it says, if it is having any linear circuit that is containing a several voltage sources and resistors, that can be simplified to a Thevenin equivalent circuit. So that Thevenin equivalent circuit, which consists of one voltage source called Thevenin voltage, is in series with a equivalent resistance called a Thevenin equivalent resistance. So that especially these three components, which are very important in the Thevenin theorems. So here the first one is a load resistor. So what load resistor they are given, that you have to know. If they are not given the value of load resistance, they won't ask you to calculate the value of load current. Okay. And one more is Thevenin voltage. So like how we'll find Thevenin voltage? Just by removing the load resistor, you're calculating voltage across that load, so-called open circuit voltage. You can call that as a open circuit voltage as well as Thevenin's voltage. And to find the value of Thevenin resistor, say that, or else you can say it as equivalent resistor. So whenever finding the value of Thevenin's resistance, we should remove the load resistance. Then if there is a voltage source that is replaced by its internal resistance, suppose if there is no internal resistance, that will be replaced by short circuit by considering a resistance as zero. Similarly, if there is a current source, that you have to replace by open circuit if it is not having internal resistance. So this much you have to write in examination. Whenever which comes to the explanation part, so the explanation is nothing but you need to take one simple circuit. You can see now I'm considering a circuit which consists of three resistors, one load resistor, say it as RL, which is connected across the terminals A and B. Okay. So first what you need to find? VTH. So to find the value of VTH, you have to remove load resistance RL. Then it is replaced by open circuit voltage, say it as a VTH. So that you can see, consider a network or a circuit. So you can consider, let E be the EMF that will be having the internal resistance of 0, means it can be replaced by short circuit, and it is having a load resistance RL which is connected across the terminals A and B. So to find the VTH, you should remove this load, remove RL, then you find voltage across this terminal A and B, that is nothing but VTH. So to find the value of voltage across the terminals, you can use any of the reduction techniques, any of the reduction technique you can use, or reduction method you can use. So here they used the voltage across open terminals. Since the circuit which is opened, so that current flows to this is 0, so that this R3 will be neglected. So the voltage across the terminals A and B is nothing but current flows to the R2, that is nothing but I, and the value of this resistor R2. So that VTH is nothing but I into R2. Okay. So can use this. Anyhow, the circuit which is the R3 which is 0. So the circuit which act as a series circuit, we can also apply voltage divider if you want. So that either you can use voltage divider directly, that is VTH is given by the total voltage E into same resistor R2 divided by R1 plus R2. Directly, you can use voltage divider rule. Voltage divider rule. Or else you can find the value of current that flows through the R2, then you can find the drop across R2, that is nothing but Thevenin voltage. So what they are doing here, they are finding the value of current I, since the current which is flowing here, so that the total current which is given by simply by applying Ohm's law E divided by R1 plus R2, that is V by R equivalent. Then VTH which is given by I into R2, you are substituting the value of I here, you can get E into R2 divided by R1 plus R2. Or else simply you can direct voltage divider, you will get the same value. My suggestion is to write which is simplified network. So you can use maximum or you can use minimum steps to simplify the network to find the value of VTH. So now to find the value of RTH, what you're doing, you're removing the load resistor. Then if there is any voltage source, that should be replaced by short circuit. There is any current source, that will be replaced by open circuit. So in this example, we'll be having only one voltage source, hence that E is replaced by short circuit. So that you can see the observe this diagram. Then you can easily find the value of RTH, that is nothing but the R1 and R2 which are connected parallel, and this combination is series to R3. So that you can write R1 R2 R1 R2 divided by R1 plus R2 plus R3. Okay. So this is your RTH. Suppose if the voltage which is having a internal resistance, it will be having a small resistor R, you can add R instead of R1. Okay. It is very simple now. Once after finding the value of VTH and ITH, then you have to draw the Thevenin equivalent circuit. So Thevenin equivalent circuit is nothing but which consists of equivalent voltage, that is nothing but VTH is in series with RTH across load resistor RL. This is in the terminals A and B. And this explanation you have to write in the examination if they ask it for 8 marks. Here they asked it for 8 marks, I think. So that you need to write these also. Now 8 marks they asked. State and explain. Statements, it may have some 2 marks. Explanation will be having some 6 marks. So statement, which is nothing but the voltage source and the resistors can be replaced by a Thevenin equivalent circuit which consists of a single voltage source is in series with the resistance across load. And to find the value of VTH, you are removing the value of load, you are removing the load resistance, then you are finding voltage across open circuit by using any of the network reduction techniques. Similarly, to find the value of RTH, you're removing the load resistance. If there is a voltage source short circuited, if there is a current source open circuited, then you'll be getting the value of Thevenin's resistance called as equivalent resistor. Okay. Then you are drawing the Thevenin's equivalent circuit, which consists of VTH is in series with RTH across load. With the help of this, you are finding the value of IL. The current flows to the load is nothing but IL, which is given by VTH divided by RTH plus RL. This you need to write. Okay. So next go for the second one. Here they asked you to draw the Thevenin equivalent circuit of this network across the terminals X and Y. So here we'll be having the X and Y terminals. So here equivalent circuit is nothing but it is having one resistor is in series with voltage source across these terminals X and Y. Here we're connecting a load resistance RL. They are not given the value of RL. Clear? RTH you need to find, VTH you need to find. So first, to find VTH, So there is no load resistance. They are only remove the load resistance and they are given the terminals. So that is just right. You need to find the value of VTH here. VTH plus and minus. Since the terminals X and Y which are open, so that current flows to the 10 ohm is 0 amperes. Hence, the circuit which looks like this, there will be 3 ohm resistors and there will be current source of 5 amperes downward which is connected across 15 ohm resistor, and here will be having one voltage source, and there is a 10 ohm of resistor, but current flows to the 10 ohm is 0. Here 0 current is flowing, I is 0 across the terminals VTH. Okay, 3 ohm, 5 amperes, then 15 ohm, then 150 volts. So this VTH is given by 150, which is already this drop across these two. That is nothing but 10 into 0 is nothing but 0. So that will be having 150 plus 15 into current flows to this. For example, I1 is flowing here and I2 is flowing here in this direction. So plus 15 into I2. So you need to find the value of I2. To find the value of I2, to find I2, you can use any method. Either you can use what mesh analysis, it will act as super mesh, or else simply you can use current divide rule. Anyhow, 5 ohm will be there. So the total current which is flowing downward, this I, the value of I is 5 amperes and I2 you need to find. So that I2 which is given by applying current divide rule, current which is flowing, total current, the main current which is flowing opposite direction, so that minus I into opposite resistor is 3 ohm now, sorry 30 ohm. Opposite resistor is 30 ohm divided by sum of resistor, that is 30 plus 15. So the main current is 5, so that minus 5 into 30 divided by 45, you can get minus 3.334 amperes. This is current flows through 15 ohm resistor. Why you are taking negative? Because the direction of current is downward, 5 amperes. So it is flowing downward, so that it is flowing opposite to the branch current, so that you are writing like that. Okay. So once after getting this, now you can find the value of VTH. So now the VTH, okay. So now this VTH is 150 plus 15 into I2. That is nothing but 150 plus 15 into minus 3.334 amperes. You can get 150 minus 50. That is nothing but Thevenin's voltage is 100 volts. VTH is 100 volts. Next, to find the value of RTH, to find RTH, if there is a voltage source, that will be replaced by short circuit. If there is a current source, that will be replaced by open circuit, so that 150 volts source becomes short circuit and 5 amperes current source becomes open circuit. This will be open circuit. Okay, so the circuit which looks like this 30 ohm resistor, hence the current source is open, so that 15 ohm which is parallel to 30 ohm, and this combination is connected in series with 10 ohm, whereas a 150 voltage source will be short circuited, and this will be your RTH. This is 10 ohm, so that RTH is given by 30 is parallel to 15, and this combination is series to 10 ohm, that is nothing but 30 into 15 divided by 30 plus 15 is nothing but 45 plus 10, you can get RTH as 20 ohm. So once after getting the value of RTH and VTH, now you draw the Thevenin's equivalent circuit. So that Thevenin's equivalent circuit is nothing but RTH is in series with VTH across the terminals X and Y. This is Thevenin's equivalent circuit. Whereas the value of RTH is 20 ohm and the value of VTH is 100 volts. And this is the solution. If you are having any doubts regarding this, Feel free to write in a comment box. So now let's go for the next problem. So now here you need to draw the Norton's equivalent circuit. Norton's equivalent circuit is nothing but there will be a current source IN which is connected parallel to RN, that is nothing but RTH, RN or RTH, sorry, RTH across the terminals or else across the load, across the terminals A and B. So for the Norton's equivalent circuit, first you need to find the value of IN. That is nothing but short circuit current. So now to find the value of IN, to find IN, so that terminals A and B is short circuited. If it is Thevenin's, that should be open circuit. So now for the Norton's, it is vice versa. It is short circuited. Then you need to find the value of current flows to short circuit. That is ISC. That is nothing but Norton's current IN. So now the circuit which looks like this. So there will be voltage source and impedance, and here the terminals A and B becomes short circuited, and current flows to this is IN, and there will be one more impedance. So now we'll be having voltage source. They are only given the polarity, so that we should mark the same polarity. Phi at an angle of 90 degree volts, and here it is 10 at an angle of minus 30 degree ohm, and this will be phi at an angle of 60 degree ohm and 10 at an angle of 0 degree volts. So IN, so here I1 is flowing and here I2 is flowing. So that IN is nothing but I1 minus I2. I already explained about this in a mesh analysis or a super mesh analysis, whatever you can consider. Okay. So now you need to find the value of IN. Okay. So to find the value of IN, now I1 and I2 should find. So that apply KVL at I1 loop. You need to apply KVL at I1 loop, so that here, so the current is flowing here. This is, they are not given, you only consider minus and plus if you want. Okay, and here plus and minus, you can write 10 at an angle of 0 degree minus phi at an angle of 60 degree equals to 0. Current flows to IN is 0. Okay, that's nothing but I1 equals to I2. So that into I1, phi at an angle of 60 degree into I1. So that I1 equals 10 at an angle of 0 degree divided by phi at an angle of 60 degree. So you can get 2 at an angle of minus 60 degree amperes. Clear? Similarly, apply KVL at loop 2. Apply KVL at I2 loop. You apply KVL at this loop now. So if you're applying KVL at loop 2 now, you need to write here plus and minus, they are only given. This is plus and this is minus based on the direction of current. So that you can write now minus phi at an angle of 90 degree minus 10 at an angle of minus 30 degree into I2 equals to 0. So that I2 equals minus phi at an angle of 90 degree divided by 10 at an angle of minus 30 degree. So probably you can get, wait a minute, minus phi at an angle of 90 degree divided by 10 at an angle of minus 30 degree. So you can get 0.5 0.5 at an angle of minus 60 degree. Divided by 10 at an angle of minus 30. 0.5 at an angle of minus 60 degree will get 0.5 at an angle of minus 60 degree amperes. So now the short circuit, that is nothing but IN, which is given by I1 minus I2. So you can get I1 minus I2 is nothing but I1, you already know, that is 2 at an angle of minus 60 degree plus, sorry, minus 0.5 at an angle of minus 60 degree. So you can get now 2 at an angle of minus 60 degree minus 0.5 at an angle of minus 60 degree and get 1.5. IN is 1.5 at an angle of minus 60 degree amperes. This is IN. Next, you need to find the value of Rn or else RTH. So now to find the value of RTH, to find RTH, first you should draw the circuit. Voltage source becomes short circuit, current source becomes open circuit, so that you can get like this. ZTH, here this is your RTH or else RN. Here there will be one more resistor or else impedance will be having. The value of impedances are, this is 5 at an angle of 60 degree and this is 10 at an angle of minus 30 degree. That is nothing but this RTH. I'll rewrite here. RTH is given by, so these two are in parallel. That is nothing but 5 at an angle of 60 degree is parallel to 10 at an angle of minus 30 degree. So that I can get RTH equals 5 at an angle of 60 degree into 10 at an angle of minus 30 degree divided by 5 at an angle of 60 degree plus 10 at an angle of minus 30 degree. So that I can get the value of RTH or Rn as, give me a second, 5 at an angle of 60, 5 at an angle of 60 into 10 at an angle of minus 30 divided by 5 at an angle of 60 plus 10 at an angle of minus 30. So you can get RTH as 4.472, 4.472 at an angle of 33.43 ohms. Then you need to draw this equivalent circuit. IN and RN value should substitute. IN is nothing but 1.5 at an angle of minus 60 degree amperes, and Rn is 4.472 Rn or Zn, whatever you can consider, 33.43 degree ohms. This is the solution. If you're having any doubts regarding this solution, feel free to write in a comment box. So very soon I'll come up with a model 3 questions from model question paper in next video. So I hope you are getting these calculations. Just take a screenshot and use the solution. If there is any mistake in the problem, feel free to write in a comment box. And thank you so much for watching this video. If you have any doubts regarding this, write in a comment box. And if you really like this video, kindly subscribe and share maximum. It may help me a lot. Thank you and have a nice day.